Okay, so this is a handout with a bunch of trig stuff on it that could be helpful as we're doing trig. Probably won't use a lot of it, but it's kind of a very thorough one sheet. And the back, I think, should have your homework for today. So we've already been doing some trig. But today's notes we're going to do on a separate sheet of paper. So this is Unit 1, Day 4, and it's going to be all about trig. So, I guess we'll go over just the basics. And so, just evaluating trig. So, like cotangent of 2 pi over 3. So, I mean, one thing is you could change it to degrees, but you really shouldn't have to rely on that. Pi is 180 degrees, so this is the same thing as cotangent of 60 times 2, 120 degrees. You should be able to work with both. So what I usually do is I do alpha. So 2 pi, this is pi, right? This is 0. So 2 pi over 3 is about 2/3 of the way right here, right? So this is your alpha. It creates that right triangle, so that'd be pi over 3. So alpha is pi over 3. Or in this case, 60 degrees. What quadrants? We're in quadrant 2. So tangent is 1 over tangent. And tangent sine over cosine. So this is going to be cosine over sine. And in quadrant 2, so we're just gonna put alpha in here. In quadrant 2, cosine is negative, sine is positive. So cosine values, cosine's like this, right? 1, root 3 over 2, root 2 over 2, 1/2. So pi over 3 be pi over 6, pi over 4, pi over 3. That's that further one. So that's going to be negative 1/2. And sine is going to be positive root 3 over 2. So that's going to be negative 1 over root 3, which is negative root 3 over 3. The final answer. So we do cosecant of 13 pi over 6. So that's right more than a full circle. 12 pi over 6 would be 2 pi. So this is alpha is pi over 6, and you're in the first quadrant. And cosecant is 1 over sine. So we're going to do pi over 6. Co with a non-co is the trick. So secant goes with cosine. Cosecant goes with sine. Cotangent goes with tangent, obviously. Sine of pi over 6, that's that first smallest angle. It's 1/2. It's positive. The answer is 2. So, all right, number 2, we'll do some equations. So equations, we'll do 1. So 2 cosine 3x plus 1 equals 0 on the interval 0 to 360 degrees. So we'll go ahead and just do degrees this time. So you want to isolate the trig. Subtract 1, divide by 2. And then you want to say, okay, well, what's alpha? Ignore the negative. When does cosine equal 1/2? Well, 1, root 3 of 2, root 2 of 2, 1/2. 0, 30, 45, 60 degrees. What quadrant? Quadrant 2 and 3 is when it's negative. That's when you pay attention to negatives for the quadrants. Ignore the negative for alpha. So we're going to write 3x equals, quadrant 2 would be 180 minus alpha, 120, plus 360k. And quadrant 3 would be 180 plus alpha, 240 plus 360k. And you just kind of ignore that 3x. Right now you just put 3x whatever's inside, and then divide everything by 3, including the 360k's. Now that 3 is going to make the period a third of what normally is. So usually we get 2 answers here. We expect to get triple the normal on it. We should get 6 answers total. 40 degrees plus 120. Like, you should know that. So If you don't get 6 answers, you should be like, I missed one. If you get more than 6, you should be like, where did that extra one come from? So 40, 160, 280, 80, 200, 320. 6 answers like we thought. You could put them all in order if you really want to make it nice and pretty. Number 3, inequalities. So 2 sine squared x plus 3 sine x plus 1 less than or equals 0 on 0 to 360. So you want to factor, you want to give everything on one side equals 0, which is already true. You want to factor it. This is kind of like a quadratic trinomial. So you're thinking like reverse FOIL. So what two things would multiply together to give you the first term? One's got to be 2 sine, one's got to be 1 sine. What two things multiply together to get 1? Well, it's got to be 1 and 1. They're either both positive, both negative. It's got to be positive because the... And then just double check and make sure that gives you 3 sine x in the middle, and it does. So then each of these, zero product property says each of these gives you a root. Subtract 1, divide by 2. Subtract 1. Now this is a special case. This is the one that bounces off the graph. Sine or cosine. Sine or cosine of whatever is when it's isolated equals plus or minus 1, plus or minus 1. That's that bounce off the graph, kind of like a repeated root. So keep track of that. This over here, alpha equals, ignore the negative, 1 to sine equal 1/2, that first angle, 30 degrees. When is it negative? Quadrant 3, quadrant 4. So x equals, quadrant 3 would be 180 plus alpha, 210 plus 360 degrees, k. And quadrant 4 is going to be 360 minus alpha, 330 plus 360k. And this one's going to be, when does sine equal negative 1? At 270 degrees plus 360k. So x equals 210, 330, and 270. Keep track of this guy. So then we're going to make a line check. And I like to put the domain restrictions when the problem on there is brackets. Okay, so 210, these are going to be solid dots. 210 in order, left to right, smallest, biggest, 270 and 330. And test the value. I like to test x equals 0 if possible, if there's no dot there, which there isn't this time, because sine of 0 is 0, 0, 1 is 1 less than or equals 0, false. True, true, stays true, false. So the answer is going to be 210 to 330. Don't break it up because those are all solid circles. If there was an open circle there, you'd have to break it up. So there you go. And last, graphs. So y equals sine x plus 1. We'll try that. Now the way I want you guys to graph it is I want one period, preferably starting at 0. So we're going to mark the period off. I want you to put the period in there in degrees and radians. You start with that, and then if there's something on the inside, then you'll divide it by that. So graph the parent function, divide by 2, divide by 2, divide by 2 to get the quarters. Now 2 is negative 1 to 0, 0, 1, 0, negative 1, 0. Light dashed line. So we're going to show our work by doing one step at a time. So that's parent function. Plus 1 is going to move everything up 1. So that's going to be up there, that's up there, that's up there, that's up there, that's up there. So then your final answer is just darkened in. Now I want you to emphasize the max and min of the graph so I know, just in case. And period should be on there. So there you go. I'll do one a little more difficult. Some absolute values in there. Okay. So I think we might need to give ourselves a little more room because this is going to make, well, we'll just go with it for now. Okay, start with the parent function. So all these are pretty much just starting with the same thing. 2 pi, 360, cut it in half, cut the halves in half to get the quarters, amplitude. Now cosine starts here, 0, 1, 0, negative 1, 0, 1, y dash line. The 2 divides the period by 2. So the period is actually pi, 180 degrees. So we work from the inside out. We do the cosine, then we work the inside out, order of operations. Then we do the -1, which moves everything down 1. So that's the new graph. Then we do the absolute value. The absolute value makes anything that's negative become positive. So this all gets flipped up to this gets flipped up. This gets flipped up. And so now it looks like that. And then the 3 is going to multiply all the y values by 3. So we're going to have to go up to 6. 3, 4, 5, 6. And so that's going to be all the way up here. This is going to be at 3. This is going to be at 3. And so this is the final answer. Should be a nice smooth curve. Darken it in, leave the other stuff. That's your work. And then emphasize the max horizontal dashed line and the min. There you go. So that's what I'm looking for. So that's it for today. And so you're going to try the worksheet assignment 4. One side and check your answers. And then if you have any questions, we'll try and help you out. So